Okay, so let's get started. This is the week 6 of the program now. So we have already finished week 5 and we are getting into week 6. So this is kind of at the end of this week, we'll be covering nearly half of the material. So I hope you are enjoying the course. Again, I do encourage all of you to have it a two-way conversation. When I say two-way conversation, means use the discussion board. Use the discussion board, post your questions there. You can even learn from each other. I encourage even you to kind of, if somebody raises a question and someone else of you knows the answer, you answer them too. It's a kind of, you don't have to wait for us to kind of give there, but answer and if you are really sure about it. So we don't want to create any confusion. Of course, every evening we are keeping an eye on the discussion board. Every late afternoon, early evening, we look at that and we try to respond to any questions you have. So go ahead and use the discussion board, and that's the forum we are using for communication. And of course, if needed, we'll be emailing you from time to time, and you're getting some administrative type of email as well. So let's get started now. So we have if you remember from the earlier week, towards the end of the earlier week, we were looking at a lot of example problems, trying to illustrate the concept that we have already learned over the last 5 weeks, how those concepts are applied in a real world situation. So we'll continue that in the first part of this first part of this lecture. We'll do some math on in terms of the vehicle routing and the collection system. Especially for the collection system, we'll do example problems on how to design a collection system, how to calculate all the numbers. And then as this course, as I said at the very beginning in the introductory video as well, the course is primary focus of this course is on Indian municipal solid waste. So because it's intended for Indian audience, of course people from around the world can benefit from the course, but it's because the situation is similar in other parts of the world as well. But here in the second part of this week, we will be focusing on and looking at the MSW management status of a few of the proposed smart cities in India. So we have several, around 100 smart cities. Out of that, 20 smart cities were in the first list. So out of those 20, we have visited few, and in the month of December of 2016. And so we have visited few, and then we have summarized out of the places we visited, we have summarized few of them in here. We have visited some other places as well. So that we will go over what they are doing right now, what are the challenges they are facing, how they can go about having a better integrated waste management framework. And if time permits, we'll start getting into the later part of this week into biological treatment. So that's what you will be learning in this particular week. So if you look at the vehicle routing, we have talked about this a little bit earlier. Vehicle routing is how, see, we were talking about the collection system. Collection system is one of the most, collection system is the most expensive part of a waste management plan. So when we are trying to design the route, it's how the vehicle will move around, and collect the garbage from different collection points. In big cities, in old cities, it will be mostly from the primary collection center. It cannot be from individual houses, especially since our lanes are very narrow. We cannot have these trucks kind of go around. So here we have those trolleys, and you will see the pictures of that. We have some trolleys where people are using those trolleys to go to individual houses. And then in big apartment complexes, it's being collected just on the gate of the apartment complex. So those, so wherever possible, we'd like to take this a small vehicle, truck, trolleys. So whatever you talk about, there is always, you have to plan a route. And this planning of the route for waste management, I think I have said that earlier as well, is very similar to what the planning would be for say Flipkart or Amazon or Snapdeal and other stuff. Because it's essentially you are moving a certain material from one point to another point, whether it's your new laptop coming through Amazon, or your cell phone coming from mobile coming from Flipkart, or you are moving garbage within city of Kolkata or within city of Delhi from point A to point V. All has the same basic concept. So it's basically optimization of the route. So that's and there are some companies totally specializing on that, where they do some route optimization. So in terms of the vehicle routing, there are softwares now which take care of that, but I will show you what exactly goes in those software. So but in terms of factors that is required is that it has to go and collect waste from each and every location. So, when it goes to each and every location, there is this loading time which is critical. So, they have to have this loading time, and some of the stuff that you can avoid, you do not want to have a U-turn, because if you take a U-turn, you are essentially killing some time. So, you are not very efficient if you are taking too many of U-turns. Sometimes you cannot avoid that, but many places you can avoid it. And again, since this is essentially coming from the Western world, they mostly drive on the other side of the road. They say the right turns are preferred. So, in Indian context, we will have the left turn is preferred, isn't it? We will like the left turn because we can do the left turn easily than the right turn here. So, we will have the left turn is preferred in the Indian context. And then other things we need to know is volume per truck, how much waste can be collected in a truck, and should we compact it, how much compaction can be done, and the travel time to the transfer station. So, those are all important in terms of factoring when we are trying to do this pickup route. We are assuming here that there is a transfer station. This could be transfer for travel time directly to the landfill as well. So, this when you design this pickup route, like you will have a worker working there, you will have driver and couple of people working with him. Total you are looking at something around like 8 hours per week. In 8 hours per week, you have to factor in the time for lunch time and some break time in between for the washroom break, but people have to go to the bathroom, some tea breaks. So, while factoring those things in there, depending on what kind of practices they have in that particular city, you will have maybe around 6 to 6.5 hours of total route time that a truck can take in a day. So, we have to design a route which is good for 6.5 hours. So, they start in the morning, they collect at several places, and then at the end of the day they take it to the transfer station, or if transfer station is not there, to the landfill. If the city is small, and you may design 2 routes like 3 hours, 3 hours. If the city is small, and then if you get the garbage collected much quickly, if your truck gets filled up. So, you have to actually look at how many houses are there, what kind of streets are there. So, these are not that easy actually. If you really want to do a scientific methodological way of doing it, it requires a lot of input. So, that is why computer programming comes in picture here as well. So, what does the large community do? That they use linear programming. So, these large communities, they use some sort of a linear programming, specifically linear programming network model. So, they use those and I'll in the next slide I think I'll walk you through how that works. So, a network, what is it? It's a set of nodes showing the different direction between how the material will flow. Again, when I'm saying material here, we're talking about the waste, and essentially waste is a resource as well. So, and then we try to do some linear like a linear programming, and you do some optimization of that. So, you can come up with an optimum solution, and this optimum solution is where one or more path you have set of connected nodes, intermediate sink node and all that, and for each node there is a flow in and flow out, because the things will come in and things will go out. So, you can have multiple sources, multiple residential areas. You can have a sink is your transfer stations or landfill. So, those are the work you can use for going into the input for the vehicle routing. So, let's I think let's look at this next slide. Yes. So, here it is. So, we have, as you can see over here, the same thing which I said earlier in the previous slide in the form of text. Here I am trying to explain to you in the form of a pictorial diagram. So, here if you look at these areas, here we have RA1, RA2 and RA3. As RA is residential area. So, I'm calling RA as residential area. So, there is 3 we have taken, and this could be like many more as well, but for our just have a simple example. So, see these 3 residential areas RA1, RA2, RA3. Now, and then we have 3 transfer stations as well, TS1, TS2, TS3. It could be just 1 or it could be 2, just for and then what you have from RA1 things can go to transfer station 1, things can go to transfer station 2, things can go to transfer station 3. When I say things, it's basically waste going into these either of these transfer station, and and then so RA1 can have things going in different transfer station, similarly for RA2, similarly for RA3. And as you can see here, different routes as well, x1, x2, x3, x4, and then it talks about some links in between. So, x1 and then the bracket, those numbers shows kind of different possibilities of the route, different number of trucks, and all those different variables are put in there. Now, from transfer station, things can go to landfill 1, and potentially it can go to landfill 2 as well. So, I am saying either to landfill 1 or landfill 2. Sometimes it also depends on the type of waste that is being collected. So, and then this all the axes are showing you the different routes which have been taken up. So, what it requires is you come up with, for say for the I am sitting in Kharagpur, in IIT Kharagpur campus. So, if we take the whole Kharagpur town and we try to come up with Kharagpur town, if you think about, those of you who are familiar with Kharagpur, we have this, of course, IIT campus is one of the you can say around a good population here. Then we have the railway areas, but railway areas is well spread out. So, if we can just take the railway areas closer to the railway station, that is also called Bangla side or south side. So, if we just concentrate on that part, so that could be our, so let us say KGP campus is RA1, railway near railway station area is RA2. Then if you just go to Kalaikunda area, just there are some other areas there as well. We have Inda, Malancha and other things, but and then there are a lot of other residential areas. But say if we just focus on these three, so these are the three, and from each of them, if we have a transfer station built up at different places in Kharagpur, how the waste will flow, what will be the route, and so those are showing you those X with that arrows are showing all these possible routes. And then it could be different possibility as well, from RA1 to TS1 it can go by different streets. So, all those things we need to take into picture. If there is a school in that area, you do not want to take your garbage truck in the school hours, or whenever either the school is like the kids are coming in, or whenever kids are going out after the school is done. So, in the say morning around 8 o'clock most of the schools open, and then around 3 o'clock, between 2 to 3 most of the schools have their closing time. So, you do not want this garbage truck going into those areas. So, all those factors we need to take into consideration different and then of course, one of the important part will be how many houses we are serving. Again, remember in the earlier slide we talked about vehicle capacity, like how much house it can take. If it is a compactor truck, how much compaction you will have it. So, and then you have 6 and 6.5 hours of work day. So, you have to come up with lot of variables are there which all needs to be factored in to come up with an optimum solution. So, this is what this kind of like a vehicle routing possibilities you will come up with, and then you will consider several factors, which is what is the time to or from the first and last home, because the garage, mostly these garbage trucks will be in a garage. So, if it drives to a particular house in the morning, how much time does it take? That should also be part of the 6.5 hours. Now, local routes, how the local routes, what is the speed of the local routes, how congested they are at different times of the day, those inputs will come from the local people, local drivers who are driving in that area. And based on that, there has been what we have, this is already kind of published together for, it's called routing coefficient. For most of the western cities it is already there. For the Indian cities we need to develop that. We need to develop a routing coefficient, and it is a dynamic number, because things are changing, especially in developing countries. Most of, say, you will have a narrow street, then it becomes a wider street, you may have some new area developing, you may have new construction going on. Earlier red light, the traffic light was not there, now traffic light is there, things may have been made one way. So, things are dynamic. So, for that this routing coefficient will also keeps on changing, but at least we need to have some sort of so what these routing coefficients are, basically it takes the information of the traffic, how the traffic flows, and then it comes up with a number. And that is how it is like if you are interested in the transportation sector, you will learn more about that. So, but that is how it is come, and we will use that number. I will tell you those numbers in a minute. And then there will be some time which for the unloading time at the transfer station or landfill. So, that time needs to be accounted for as well. So, all these things needs to go into the route. And So, there is a need to consider what there could be different options. There could be a local landfill, there could be a private landfill. The decision variables or routing time through the network, we will look at that. Objective is to minimize routing time. So, that is the main objective we have, is to minimize the routing time. Why? Because as you know, time is money. If we can minimize the routing time, we can have more houses being served by the same truck, and that will mean less number of trucks, and that will mean saving of money. So, it is all kind of related with that. So, constrained of course, the travel time along with each route, and then capacity of the truck or transfer station as well, and then try to conserve the material at the different nodes. So, and this is a kind of whenever we start doing it for a one particular city or town, it will be like a work in progress for first few years. You will not have like a perfect solution on first go, because you come up with one, you operate within the actual scenarios, then once you get some more information, then you refine it by trial and error and through the use of linear programming model. So, this is how things gets evolved over time. So, as I said earlier, there are actually some companies which deal with this kind of routing system for the like a waste management program, for waste management system for different cities. So, there are companies, and they are the same companies who works with like railways or work with Amazon and Flipkart and all those things as well. So, just another kind of whatever we talked about, just kind of summarize in a pictorial way again. Just to goal here is to make it very clear to you that how this software works, because what happens in most of the time, if you are doing this work, you will be using a software and then you do not pay any attention to what the software is doing, which is not at all correct. As a designer, as a waste management engineer, we need to know what the software does, what are the inputs are, and how we have to how we can optimize things using those softwares. So, here in terms of the routing, how we take the route timing, the timing that it will take. So, in the morning, say this is the public works garage, as I was telling you earlier. Let us see, this is your public works garage, where the truck will be in the night time. So, in the morning they will start driving. So, from the time T1 we have to encounter that. Say if you have to calculate the route time, you have to calculate the time that it will take to do one route. So, from public works garage it goes to the first house. So, that is the time T1. So, we need to account for time T1. Then we need to account for time T2 is what is from the last stop after it does its thing, and if it wants to come back to the public garage. So, that is the time T, and then the important time is pickup time per trip. Pickup time is how much time it takes to pick up the garbage at each of the houses that it stops to pick up the garbage. So, that is called PHCS. So, we will be using lots of terminology here. Again, you will have several terminology, and so like maybe the size of your program, like a problem description may be like a big, but do not worry about those, do not get intimidated by that. Collect all the data points that you have, and then you work out the problem. As I said earlier, most of the solid waste in general, even environmental problems, are pretty much straightforward, as long as you break it down and do task by task, like a step by step. So, here PHCS is pickup time per trip. Now, what is the pickup time per trip? We will serve several houses. There will be several houses that needs to be served. So, all these houses, each house it will stop, say at least for 30 seconds or 40 seconds or sometimes even for a minute, depends on the type of the truck, how many person in the truck doing the service. So, we have to calculate this PHCS, that will be kind of pickup time at each locations multiplied by the number of locations plus the travel time between locations. So, many times what we do is actually the travel time between locations, we club them together with the pickup time. So, because this is essentially the whole time it will take for the garbage truck to get filled up. So, once it filled up, it can go to a transfer station or it can go to a landfill. So, in both cases the time is required. So, that is the haul time. This is the H. We call it H, that haul time. What is the haul time? They are basically hauling the garbage, no more additional of garbage on the truck, it is just hauling the garbage from this last point to the transfer station or to the landfill. So, that is that part, and then S is the time that it takes at the site, either at the transfer station or the landfill, to empty the truck, and then again the whole process will continue again. So, this is the one round trip, and that is called THCS. So, one round trip, the terminology uses THCS. So, that includes the entire time, collection time at the houses, time to the landfill, time to the transfer station, and the time back to the residential area, to the next house. So, that is your THCS. So, this is how you analyze the route timing, and that is we will do the math using all these different terminology in a minute. So, pickup time, these are the equations. These equations are available in the book. You can pick up, this is again, I think I mentioned to you, there is a book by Subangulash. You can, this is one of the, like a Bible for waste management. Book is old now, probably it is time for write a new book, and I hope to do so in near future. But it's a pickup, so we can but this you can look at that Subangula's integrated waste management, solid waste management book, which should be available in any library. But if you do not have access to it, most of the information I have already provided here. So, there are equations which you can in the book. So, this is the equations has been taken from the book, and which is you can look at the reference, or so for the pickup time for the hall container system, this is an hall container system. So, where we are hauling the final like the once the truck is pulled up, we are taking the truck to the disposal point. So, here THCS, which is the time for a round trip, hour per trip, is in combination of, again it is a very simple straight math with the simple if you just use your common sense. Now, the total time for the round trip will be what? Just it is the time for whatever time it takes from the last place where the truck got filled up to the transfer station or landfill. Round trip, we can take the round trip time. So, that is one time we need to account for. There are some, that is what is H is given in the equation. Then we have S, which is the time at the landfill or the transfer station, depending on the case. Again, we have to take out that time. So, we have accounted for the hauling distance, hauling time. We have accounted for the time it takes at the landfill or the transfer station. Now, what is the time left? Is the time that it will collect garbage from each of the houses. So, that time needs to be taken up as well. So, that gives you the total time for garbage to get filled up in the truck and gets disposed at the transfer station or a landfill. So, that is one part of it. The other part is the time from the garage to the first house, and then the next other part is from the last house that is served on the day back to the garage. So, that time is also there, but that will take into factor in a minute. But here the timing for each round trip we are talking about, for the round trip for just the garbage collection. So, the pickup times PSCS and at signs are typically constant. So, PSCS and S it's actually factor of, it's under our control, isn't it? We can go from each of the houses. We know kind of those residential area, not too much traffic probably. So, we can go around each houses and we can collect the garbage, and then we can make it as efficient as possible. And we can do that. How much time it will take at the transfer station or a landfill, that also pretty much is in our control. What is not in our control is the time H, because H is the haul time on the road, where you are competing with the same road space with other vehicles in there, and depending on what is going on in that particular city at that particular time, your H will vary. So, that is H depends on both the haul distance as well as the speed along the route, like what is the speed limit, and like what are the other traffic conditions in that area. So, all these things depends when you go for this value for H. So, H is calculated based on field data. As I said earlier, those are your what is known as the coefficient. So, based on the field data, using the field data, we get these values of A and B. So, H has been defined as A plus Bs, where Bx. So, using the field data for various types of collection vehicle, the haul time is approximated by a straight line relationship, where A and B are empirical constants, and these constants are based on the traffic conditions. And if you are more interested in how these things are done, how these things are developed, I will recommend you to read some transportation books where they do all this kind of calculation. And for the solid waste, just believe me or just trust me on the fact that this can be a linear relationship, where A and B are the empirical constant based on your traffic conditions, the way the roads are, if you have a narrow lane, single lane, double lane, 4 lane, all those times things are getting factored in. So that is your A and B. X is the average round trip haul distance in miles per trip. Again, here remember this is in miles per trip. So we need to convert things to miles. Why it is in miles per trip? Again, these are this was developed in US, and US they still use miles. So they have developed it for themselves. So they are using miles. So it's in miles per trip. So we know 1 mile is 1.6 kilometers. So we can always convert that and then use it for miles. Or as I was telling you earlier, we need to actually develop our own A and B values for the different cities in India as well. So the empirical constant A and B are site specific. It depends on the speed, depends on the type of container, depends on the size of vehicle, number of employees per vehicle. So if you are working on a company, your new employer will provide these to you if needed. So you will get these values from them. So that those values will be available to you from the new employers, from your company, from the consulting company. So this is again, this is the same equation from the previous slide. If you remember from the previous slide, this was the same equation. Just if you go back to the previous slide for a second, this was P, as you can see, this is the same equation here that we are using. And but what we did, instead of H, we expanded the value of H, and now we have H is equal to A plus Bx. So the same equation is changed to this format. So we got THCS, we can calculate PSCS, we can calculate H, because we know how much time it does for each houses, we know how much time it takes, and then if you have the value of A and B, and we know the distance X miles per trip, we can get the value of this TSCS, which is the time of collection and hauling for a truck. So once that number is there, we can calculate number of trips per day. So how we do the number of trips per day? So again, you remember said there is a work hour of around 8 hours per day, but there will be certain off route factors. For example, there will be some lunch break, there will be some bathroom breaks, there could be some tea break, cigarette break, and all those kind of, it's a fact, the workers will take those breaks. So better you accommodate those time in there, so that everybody is happy along that way. So you have the off route factor. So that is that is there. So there is we take it as a fraction, and T1 is the time to drive from garage. We already talked about that. T2 is the last one. TSCS is the time for one round trip. We already calculated how we can do this. So if you look at the numerator here, what we have here, H is our length of work day. So it's taken 8 hours a day. Out of 8 hours, there will be certain off route factor like lunch, pit stops, and all those breaks. So we have to factor in that over here, and so we get total like a work time minus the time taken for garage to the first location in the morning, and from the last location to the garage in the evening. So we have to take those numbers also out. So that minus this number gives the time that we have for the garbage collection at each of the houses, plus taking the garbage to the transfer station or landfill and dumping the garbage over there. So those are again if you follow in a logical way, these are not that difficult. It's simple, like common sense, that whatever time you have available divided by time taken for one trip will give you the number of trip, isn't it? So the number of trip that can be made vehicle per day is so that we call it ND, is the time available, total time available, which is the numerator, divided by the time taken for one trip. So if it's say total time available is 6 hours, and then if it takes 3 hours to do, so it can do 2 trips. And if it does less than 2 trips, it can be 1.5 trips. What does that mean? That means that it will do 1 trip, and then the next half trip it will get the garbage collected, but it will not go to the transfer station or the landfill. It will just stay in the garage, and the next day it will start again filling up the truck, and once the truck fills up, then it will go to landfill or the transfer station. So this is how you calculate the number of trips. So once we have the number of trips, we can, based on that, we can find out how many trucks we will require, and how many, based on number of trucks we require, we need to find out what is the manpower requirement. How many people will be required to manage these trucks, to run these trucks and all that. So these are some of the basic calculation. This is how it is done. So this is I think I have gone over the basics of how the collection system is designed, how we get all those numbers. Now the next we'll do in the next video, we'll go over a math where all these equations that you have learned in this video will apply in the next video, and you will see how the numbers are calculated. So just to illustrate so that you are comfortable in terms of designing. Again, designing good collection system design is very, very critical for a good waste management system, and that's collection is the most expensive part. And as you will see in the later part of this week as well, when we will talk about some of the upcoming smart cities in the country, even those cities are even struggling for having a good collection system. So good collection system is a must for a good waste management system. And for good collection system, you need to do this kind of math to come up with the solution which will really work, so that the trucks are working optimally, the drivers are happy, they know that it will take that much time, and of course we need to take their inputs, especially when you are getting those A and V values. We should not just get an A and V values for some US cities and then just plug in here and use it. Of course, to start with we can do that, but once we refine our process, we need to tinker that A and V values to make it more realistic for the Indian conditions. So with that, let's close this video, and then I'll see you in the next video where we'll continue with that example problem on this. Thank you.